The name of this topic is linear relationships, right? And everything that we have done is been drawing straight lines or finding distances of straight lines and that kind of stuff. This last little part, just one little section, is on non-linear relationships. So looking at things that are not straight lines, some curves. And it says here there are many situations that produce graphs that are not linear. These involve terms like an x squared. As soon as you see an x squared, you know it's not going to be a straight line anymore. Or a 2 to the power of x, or even some number over x. As soon as you start doing these more unusual things to the x, they're no longer straight lines. The most common non-linear graph that we're going to be looking at is the parabola. Okay, a parabola can model the path of a ball through the air, like a soccer ball after it's kicked. Like a straight line, a parabola has some key features, and we're going to draw one right here. Remember when we did a straight line? The first time we did it with one of these tables. So we're back to our table again. I've given you an equation, which is y is equal to x squared minus 1. And I've given you a whole bunch of x values there that we need to sub in. The first x value is minus 3. So you need your calculator. We're subbing in the minus 3 where the x is. That means, because it's x squared, it means we need brackets, minus 3 in brackets, and we need to square it. If you don't put the brackets in, it won't square the minus, which means it will mess it up. So anytime you're putting a negative number in and you need to square it, always use brackets, please. And then minus 1. Because this is the x squared, and minus 1. That was my formula. If I press equals, my first answer is 8. So underneath the minus 3, we put an 8. You don't have to retype it every time. My next x value is minus 2. So if I just use my back arrows and I delete the minus 3 and I change it to a 2. Okay? And the next answer is a 3. Does that make sense? Are you guys doing it on your calculators as well? Okay, try the next one. I want it to be minus 1. So use your back arrows. What do you get? I'm not doing it because I want to see if you guys can do it. Change your minus 2 to a minus 1. What did you get? Don't be shy. Okay, so you got your calculator. All you're doing is backtracking in here, and you're changing that minus 2, and you now want it to be a minus 1. What do you get? Press equals, what do you get? I'm not showing you. You've got to type it in. Nope. Should be 0. Do you have yours in brackets?
I got minus 2.
You got minus 2 as well? Is your brackets around the minus 1? Let me have a quick look. Oh. Close brackets, and then squared, and then minus 1. Yeah? Okay. Equals, yeah, 0. So, I don't know, maybe I had a bracket in the wrong place before, but it should be 0. Okay, so let's do the next one. It's only the number in the bracket that's changing. My next number is a 0. So you go back arrows again. Delete the minus 1 and put a 0 in there. Press equals, what do you get? Minus 1, good. Now change it to a positive 1. What do you get? Or just a 1? Yep, 0 again, good. Change it to a 2. Do you get 3? And one last one, change it to 3. And we get an 8, right? So sometimes I think getting the numbers in your table is probably the hardest part. Once you get that, hopefully the sketching is easier. We've got a lovely big Cartesian plane here. Remember, we need to put numbers on there. Because we've got so much space, I think I might go up by every second grid line. So it's going to be 1, 2, 3 going that way, and minus 1, minus 2, minus 3 going that way. That will just help me spread it out a little bit more. I don't have enough space to do that for the y-axis though. I'll just have to go up in ones. So 1, 2, 3, 4, 5, 6, 7, 8. So your x-axis and your y-axis do not have to have the same scale, but you can't change scale partway through the x-axis or the y-axis. The whole axis has to be the same. Does that make sense? All right, so plotting our points. Our first one was minus 3, 8. So remember, x-axis first. Go across to the minus 3 and then up to 8 and put a dot or a cross if you prefer. The second one is minus 2 and then up to positive 3, put a dot. Minus 1, 0, means it's still sitting on that axis right there. Next one was 0 down to minus 1, put a dot. 1, 0, put a dot, and you can see that it's kind of turned around. We're going in a different direction now. 2 goes up to 3, and the last one was 3 up to 8. So this is not meant to be a straight line, it is a curve. So you don't use a ruler to join these up. You have to, with freehand, join those dots with a lovely curve. Now, it's not pointy at the bottom, it's still curvy down here, curves all the way around. And we put arrows on the end to indicate that that parabola would keep going up if we chose to do more x values. And that's what a parabola looks like. We can change the steepness, we can move it up and down a bit, but that's the basic shape of a parabola. You've managed to draw a nice one? Yeah. They are nice and symmetrical. So once you've found the lowest point, to see how it went down to minus 1, and then it started going back up again, it was sort of following the same pattern of 0, 3, 8. See, 0, 3, 8. They're symmetrical, which can save you some time once you find that lowest value. Okay, so here is a couple of different names of things on the parabola. So a parabola is symmetrical, and the line that where it's symmetric will be called the axis, whoops, let me use my highlighter, the axis of symmetry. So this line here, where it cuts the parabola in half, that's the axis of symmetry. The point, the lowest point there is if it's, we call this one concave up because it's coming upwards, the arms are coming upwards. That's a minimum turning point. Whereas this one over here, this is a parabola that's concave down, it's going downwards, and that is the maximum turning point because that's the highest value it gets to, the maximum value that it gets to. Okay, so there's just a few different names. Here is another type of graph called an exponential graph, but I think we're actually going to leave that one because that's not the one on the test. So we're going to save ourselves some time. We're going to go, no, not going to do that one. Not going to look at the exponential, so let's just cross that one out, put a big line through it. Not going to do the exponential. We want more revision time. Cross off the exponential. We just want to do a parabola. So let's start. Okay, we're not even going to do that. You don't need to do that. The only thing that you need to be able to do is to draw a parabola. The last question on your test, okay? So here is a couple for you to practice. Just do a few of them and then we'll start our revision. So how about we do question 1, question 2, question 3 and question 4. And I think that's probably enough. We won't do any more after that. We'll just do 4 of them, hey? And start our revision.